Welcome to this presentation on cricket ball trajectory prediction. My name is Mohammad Akif. Today we will walk through our Jupyter notebook, which uses deep learning to classify cricket deliveries based on bowler grips. In the first code cell, we import all the necessary libraries, including TensorFlow, Keras, and for deep learning models like ResNet50, OpenCV for image processing, and scikit-learn for performance metrics. The output confirms that all the libraries are imported successfully. Moving on to the second cell, um, we define the path for our dataset and load the class labels. The output displays the 6 trajectory classes such as googly, swing out, flippers, leg spin, swing in, etc. As the class labels, the output, and then the third cell, it defines a very simple helper function, get label, which maps these string names into numerical IDs for our model. Now, within the fourth cell, we load and process our images. If the processed data isn't already saved, we read each image using OpenCV, resize it to 64 by 64 pixels, and we append our image to the feature array, which is X in this case, and then um, the output shows that a total of 272 images were found and uploaded. And then the fifth cell visualizes this dataset. We use matplotlib, which is the mathematics plot library, um, to plot a bar chart showing the count of images per class label. As you can see, googly is 20 images, and then swing out is a little over 20, so on and so forth. And then in the sixth cell, we verify our image processing by displaying a single sample image converted into RGB format, as you can see here. And then the seventh cell handles the final pre-processing step. We convert our image pixel into float 32 as given here, and then we normalize them by dividing by 255. Then we shuffled the data and split it, as you can see here. The output indicates that 80% of our data is used for training the algorithm, and then remaining 20% used for or 55 images reserved for testing. And then in cells 8 and 9, we prepare the model for evaluation. We initialize global lists to store accuracy, precision, recall, and F-score. We then define the calculate metrics function. This function not only computes these metrics using scikit-learn, but it also generates a confusion matrix heat map to visualize how well the model predicts true classes versus predicted classes. And finally, in the subsequent cell, uh, we can implement our transfer learning model, specifically ResNet50. We load the pre-trained weights and evaluate it on our test set. The output reveals our model's performance. ResNet50 achieves an overall, as you can see here, ResNet50 achieves an overall accuracy of roughly 85.45% and a precision of 89.94, and recall of 88.92, and the F-score of 89.38. Now we can see here an confusion matrix showing the current predictions. Now that is it. Thank you very much.